Hi everyone, it's Mr. Ekstrom. Taking a break from watching Celebrity Family Feud to do a little bit of... That says I love math. That doesn't say I love math, by the way. Let's just see if this guy knows what he's talking about here. If you would please get out your textbook, page 542, and I'm going to do some sample problems. I'm also going to try to get this guy off my screen here. Let's see, what if I click this button here? And then we'll see the homework. This is on page 542. I'll read a little bit of the problem. A New York Times poll on women's issues, and we asked 1,025 women, do you feel like you don't get enough time for yourself? And then we got a result. So we're talking about taking survey results and turning them into confidence intervals. This question basically asks, let's see, how about blue? Do you know what a confidence interval is? It's these two things. The problem 1A here is just breaking them apart. We got a result of 47% plus or minus 3%. Well, what is a confidence interval? It's those two pieces put together. And when you do the plus or minus, you get a confidence interval of 44% to 50% felt that they did not get enough time for themselves. Can you say that's the result? 47% of American women feel this way. Well, no, that's going too far. To be more careful, you want to say something like this. This is a sample, and our sample percentage has estimated the true percentage of women that feel this way. Now, what if someone has never heard of a confidence interval? Maybe you've never heard of a confidence interval. In that case, you should probably look at the video notes before you look at this sample problem. But we want to say something about the interval being more or less certain and not talk about the true parameter having a chance of being something. The true parameter is out there. There is a percentage of women that feel this way. We don't know it, but we're estimating it. So we say our interval, not the true mean, or the true percentage, but our interval has a 95% chance of capturing the truth. Number 2 goes into great detail about the NEAP exam or assessment, and specifically how it applies to math literacy. But what we're really interested in is what kind of research did they do here? Well, they asked 840 people, and I do not have my pen on, so let me try that again. They asked 840 people, and they know, they give us a reason that somehow we know what the population standard deviation is. And we are going to take the sample and get a mean of 280. So that gives us, I'm sorry, they're telling us over and over again that the sample means are going to target the true mean. So here's one of those situations where magically we know, and it could be because of millions and millions of observations, we know the parameters. Well, what would the shape, center, and spread, the shape, the center, and the spread of the sampling distribution look like? So this is really going back to the beginning of the semester, describing a distribution. Well, the shape is a bell curve. How do we know that? You should probably say something about how you know that. Because the sample size is large enough that the central limit theorem tells us that this sampling distribution will be bell-shaped, even if the population isn't. What about the center? Again, central limit theorem tells us that if we have an unbiased estimator, that sampling over and over again will target that true mean of 280. So there's the shape in the center, not too tough. It's symmetrical, it's bell-shaped. We've got a center of 280, 280 points on this test. Spread, we actually have to calculate. They gave us a population sigma, and now we're going to take the sampling sigma. Remember, central limit theorem says the sampling sigma will be much smaller. How much smaller? Divide by square root of 840. and 60 drops down to 2.07. So we'll just call that 2 points, and then they asked us to do this up here, and that is to draw in 1 standard deviation away from the mean, and then 2 standard deviations from the mean, which might look nice in a different color, and then finally 3 standard deviations from the mean. And since that's just counting by twos, that's not too hard to draw there. The empirical rule, you may remember, talks about 95% of the values falling between a negative 2 sigma and a positive 2 sigma. Well, there we have those values of 270. I've crossed them out, so maybe I should write them again. 276 and whatever 280 plus 4 is. Not writing very well, but that says 284. 2D asks us about 2 sampling situations, and I made these numbers up, but they said to make one up that has an interval that captures the true mean here. And now let me put the true mean in red, and as I said in some previous notes, truth is not moving around here. There is a mean, it exists, we were told it's 280, and it's like a pole set in concrete. It's not bouncing around with randomness. What is bouncing around are the possible sample means we'd get when we do a survey. That's where the variability comes in, and that's why we use an interval. And the interval in this situation with a 282 at the middle, it does have an interval that captures the true mean. This is really well illustrated on page 541 in the book, so if you take a close look at that, this idea of how truth stays in one place and our sampling intervals with our sample mean and the interval around the sample mean, those are the things that are varying, and 95% or whatever percentage, 95% of the time, those intervals are capturing truth. And here we see in this situation, captured truth. And now, a rare situation, according to the bell curve, 287 is way out here with a very low probability. But let's say we get unlucky, we do a sample, we get 287, we can come up with this confidence interval, and we've missed it. And that's why, statistics is not about 100% certainty. This situation could come up, and we would miss it. So we say something like this. Again and again, we're practicing how to put this into English. What is a confidence interval? The true mean will be covered by our interval estimate 95% of the time. Or to be exact, because it's really it's a z-score of 2.0, not 1.96, that percentage is a little bit more than 95%. Let's take a look at 5 and 7 in a separate video. See you there.